To begin with Newton's universal law of gravitation, we've got to consider a famous story regarding Newton. And that would be the story that you may have already heard in your scholastic career, or maybe just heard of it in the general public. And so I apologize for those who don't care for the stories, but it's an important part of the background here. I know some of you just want to give me the equation, but nope, story time. I apologize. You know who you are. You know who you are. It's a story about the apple falling on Isaac Newton's head and suddenly him claiming out gravity. This is gravity. So he discovers gravity because an apple falls on his head. Like nobody knew that stuff fall before and suddenly it's gravity. That's not quite the story. That's a myth. And so a more accurate version of the story deals with Newton perhaps leaning against an apple tree. Now I don't have an apple. The best I can do is this onion. This white onion. So onions unfortunately don't grow on trees, but the idea is kind of the same. So maybe the onion falls while I'm hanging out under the onion tree. There's no onion tree, but it goes boom. Maybe it falls beside me. Maybe it fell onto my head. I don't know. And in Newton's day, it happened to be that the moon was out at the same time. So perhaps it was the evening. Okay, so he's looking out and he sees the moon and an object falling. And right then and there's an epiphany. He realizes something very, very important. And that is this. Now, Newton, of course, the inventor of Newton's laws of motion, right, Isaac Newton, recognizes from his own experience in developing these laws, like the first law of motion, that objects should continue in a straight line at constant velocity unless acted on by an external force. Okay, so he's looking at the moon, he's like, why is the moon continuing to wrap around the Earth? Why does it circle around the Earth? What's going on? What gives here? How come it's not just flying off on its own in a straight line away from the Earth? Something must be keeping it in that circular pattern, in orbit around the Earth. And when that apple falls, he recognizes that, wait a minute, the thing that fell onto the ground is the same force that's keeping the moon in orbit. It's keeping it trapped around the Earth. This force is what he ends up calling gravity. That's where the gravity comes from. People knew things fell, but where Isaac Newton was probably a true genius in many regards, but certainly in this one, it's making a connection that nobody had before. That connection was one that linked the Earth with the heavens. See, prior to Newton, the heavens were a separate place. It's kind of, a mystical place. Perhaps religions and theology thought it's the aftermath of what happens or where you go after you die if you've been good. But or it's just a place where the gods lived if you're part of Greek culture, okay? And that was in the stars and the clouds and all that. Well, now, mind you, there were no flying machines in Newton's day, so still, the moon and the sun and the stars were regarded as a different place than on Earth. And what he realized is that the same stuff that happens on Earth, gravity, that we see, things falling towards the center of the Earth, have everything to do with what's keeping the Earth in, the moon in orbit around the Earth. He linked the celestial with the terrestrial, space and all the objects there with Earth as we know the things around us. And that's a really profound thing, because that was not the thought pattern at the time. So that's where the true genius is. He really linked two things that we now know as pretty much the same place, our universe, our solar system, our galaxy, etc. But back then it was pretty revolutionary. So what he realized is that the moon would circle around the Earth and there had to be some force bringing it in. And because it's circling around the Earth, what we have just learned about is this thing called centripetal force. There has to be a force that is going to point towards the center of the Earth. And this centripetal force he called gravity, all right? And he also noted that all the objects that fell on Earth were subject to the same force. This is the force of gravity. So that link gave him a clue as to how to explore this new phenomena that he coined gravity. Prior to him was another scientist, a very prominent one, by the name of Johannes Kepler. And in the early 1700s, he studied planetary motion. He took data from a scientist who didn't really understand like the theory of the math, but he was good at collecting data, making observations with telescopes, the optical instruments of their day, and tracing the patterns of the planets. This man's name was Tycho Brahe. Pretty cool name. Tycho, not really a popular name with people today. Might be something you want to name your dog or cat or something like that. So Tycho Brahe was the guy who produced the data. Johannes Kepler was the guy that analyzed it. And what he did was developed what are known as Kepler's laws of planetary motion. So they're a little different from Newton's laws, which are about the real foundations of physics. These are more about empirical observations. So the data that was collected by Tycho Brahe, he combined with mathematics to describe the orbits of the known planets. Now, mind you, some of those telescopes weren't so powerful, so I think they probably went as far as Saturn, maybe Uranus, Neptune, I'm not sure, but they certainly hadn't seen Pluto, which has been since demoted anyway. That's a dwarf planet, by the way. But hey, that's okay. So there are 8 planets, maybe they knew about 6 or 7 of them. And so what he did is just created a mathematics that accurately described where the planets would be, like the motion of the planets, that he would look and be able to predict exactly where they would be based on some of the data that he fit into mathematics. And mathematics is a powerful tool to be able to predict where things might go, okay? It had no foundation rooted in physics as to explain why the orbits are as they are. And so Newton comes along later, and this idea of gravity, the thing that's holding the moon in orbit around the Earth, might be useful in helping describe exactly why, mathematically, why this all happens from a foundational perspective of physics. So he would actually be able to describe the physics that actually works with keeping the planets in orbit around the sun, and then we'd be able to use that prediction and really, understand the foundations of the universe that much better. And so that's what Newton did. So next, that's exactly what we're going to discuss. What was Newton's findings that were so important? This thing called universal gravitation.